I'm here at the River Thaw in the centre of the Thaw Valley. This is a small stream and it doesn't appear that this is what created the Thaw Valley, and that's what we're trying to discover, what really did create the Thaw Valley. We theorised mainly about an ice sheet and possibly the meltwater coming off of that ice sheet causing the formation of these valleys. But we are here today to see whether those theories are correct. We're going to go and see some of the boys now, see what they're getting up to. Right. Hi, I'm here with Geology Team 1. Introduce yourselves, boys.
Hello, my name is Ian Berger.
I'm Danny James.
And what are you here to do today?
I'm the team leader of the georesistivity team, where we're going to punk a bunch of metal spikes into the ground and send an electrical current through it, and basing that off of the resistivity of different rocks, make a underground map of the geology of this area.
Very nice, thank you boys, we'll catch up with you later. Here with more members of Group 1. What are your names, guys?
I'm Layla. I'm Emily.
And what have you guys just done?
We've just laid out the cable, as you can see over there.
Awesome. Right, thank you guys, catch up with you later. Right, I'm here with some of the members from Group 2. Introduce yourself, boys.
Hi, I'm Jacob. I'm Oliver.
And what have you been doing today, boys?
So we've been pinning and hammering little pins into the floor.
Aye.
As you've seen along here, along a little transect. And what we're going to do is we're going to run a current through them and check for the resistivity of the ground.
Awesome. Thank you, guys. I'm here with the remaining members of Team 2. Introduce yourselves, guys.
I'm Morgan.
I'm Yorath.
Hi, I'm George.
Awesome. Thanks, guys.
So, Yarin, what are you about to do now?
We're about to start putting in electrodes. We'll hammer them in about to the halfway mark to allow a transformer to pump an electric current through it, which will allow us to see the ground by measuring the ground's resistivity.
Very nice.
Hello, Danny.
Hey, Owen.
What is it you're doing here?
So we're going to hammer these nodes into the floor.
Yeah.
They're going to pass a current through the ground, and that's going to help us, read the resistivity. So if I just hammer this in, Dan's going to connect a wire.
What does that do, Dan?
Well, that
It
passes-
connects it to the takeout point. And
Oh.
there we go.
Is that it done?
Yeah.
Brilliant.
Hi, so I'm here with Yarin. Yarin, has there been any issues? Anything?
A sense of the strenuous amount of labour that's required with carrying boxes or bags of wires, we are going to have to go trekking into a giant hedge line, and there's no fence around it, so that'll be fun, I suppose. But yeah, it's the only problems that I've been dealing with.
Right, I'm here with Emily. She's going to tell us all about this iris system.
So we've connected the wires with the electrodes on it into both plugs here. And so the one on the left side is for the electrodes 1 to 36, and the one on the right side is from 37 to 72. And when we turn it on, it will do like a res check to make sure all the values are okay. And then it will start like constructing a resistivity profile. And
Awesome.
then, we can use that to find what's underground.
Awesome, thank you very much.
Hello. Could you give us a brief explanation of what's going on here?
Okay, so we've just put down loads of electrodes into the ground, and in a bit we're going to zap the ground, and we're going to measure the potential and current to give us a resistivity value of the ground below the surface, and then we take loads of measurements, and that'll give us like a resistivity profile, and this will help us to identify what rocks are beneath the surface, because different rocks have different resistivity values.
Alright, I'm here with Yorath. He's part of Group 2. What are you doing here, Yorath?
So I'm just pouring a bit of water on the pegs to increase conductivity, which will help with the reading of them the survey. So.
Yeah, alright, awesome. Thank you.
So I'm with Ollie from Team 2.
Hello.
Ollie, what have you learnt today?
Today I've learned quite a bit of things. I've learned how to check for the current through rocks, and I've learned which rocks actually hold a current better. I suppose also I didn't know any of this, didn't know how to do any of it, so I think it's quite interesting the way you go through, hammer pegs in, and you then put a bit of water on them, connect them to a wire, and then it checks for resistivity, checks for the electric current through it. So yeah.
Yeah, thank you.
Right, I'm here with Morgan from Group 2. Have you encountered any issues today, Morgan?
The issues that we've encountered has been that because of the field behind us with all the cows in it and the big electric fence running along here, we've had to cut the line a little bit short. So instead of doing 5 metre intervals, we've had to do 3 metre intervals, which has been fine. It's just we've lost 9 metres, which would have been ideal if we could have had it, because we could have then maybe gotten up to some of the bedrock, but it's fine as it is. We'll still get the same. We've got the full length of the wire.
That's good, that's fine.
You're just getting your with it.
Alright, I'm here with Ollie from Group 2. Walk with me, Ollie. We'll follow Jacob. Do you want to give us a brief explanation on what Jacob's doing right now?
So pretty much after we put the pegs in, they kind of don't mean anything afterwards. So you need to make sure to plot it correctly through this device here, which then plots it on Google Maps.
Oh, okay.
And you just kind of follow your line, follow where the pegs are.
Right.
Just press the button and it goes up. So you've got peg 1, peg 2, peg 3,
Okay.
or whatever you've named them. It goes up number by number, and it just kind of shows you exactly where you've done it, how far the spaces are, and things like that.
Awesome. So if we find any features, we know exactly where they are. Awesome. Thanks, Ollie.
That's right.
Hello, I'm here with Yayan. Yayan, what was your original prediction for the formation of the valley?
My original prediction when I first saw it was that it was some sort of giant ice sheet moving through it, because the valley is gigantic and it's super duper steep at either sides. I also thought it might have been through a sill, or not a sill, a syncline, just because you had that nice curve through the valley, and I thought there's got to be some sort of weakness, and there's a bunch of thoughts about. We don't truly know if that's true now, but what we do know is that it was probably not an ice sheet. There was likely ice involved in it due to just the size of the valley, but it looks more like some sort of glacial river that's flown through it as you got.
Hi, so I'm here with Dan. Dan, can you please give us an overview of the site?
Yeah, so the site that we're looking at is the Thaw Valley, just north of Cowbridge, here in the Vale of Glamorgan. The valley we see there today is a U-shaped valley, so it's got quite flat, broad centre, and the sides are very steep, and they're defined by the tree line that we see there. So the river Thaw that is currently here today is what's known as a misfit stream, because it's very small, doesn't have much energy, and ultimately couldn't carve out of the valley that we have there today. So we know that that is not the reason we see this valley. So the whole point of this is we're sort of going to see what's happened there.
Hi, I'm here with the members of Group 1. They're going to tell me all about the conclusions that they have made from their results.
So we concluded that the valley was formed from glacial outwash, because originally there was a small river which would have formed the path for the glacial outwash to flow down. And so as the glacier starts melting, obviously a lot more water goes into the river, and that forms a much larger valley. And the fact that it meanders shows that it must have been a river forming it, and it couldn't have been a product of glacial erosion, because otherwise it would be a straight valley.
And also from our data that we've collected, we've concluded that due to the low resistivity values that we're seeing on the resistivity profile, that it's likely that the sediment above the bedrock was clay and other finer grained mature sediment. So that's also suggesting that it was a glacial river deposit rather than glacial erosion, because the glacier river deposited the finer sediment as a result of the energy diminishing as you get further away from the northern ice cap all the way down to Site 1, which is where we collected the data.
Awesome, thank you guys. Right, I'm here with some of the boys from Group 2. Tell me what site you were at and what test you were taking part in.
Hi, we were at Site 2 and we were doing the resistivity test.
Awesome. Right, what were your findings, boys?
So what we pretty much found was that the closer to the outside of the meander of the valley, the further down the bedrock was, which suggests that if it was a river, then that would be the higher energy part, which would mean there'd be more erosion there, which makes sense if there was a river there. And because we're at quite a narrow part of the valley, there would have been quite a high energy, which explains the quite sudden drop off in our results, which and then we saw there was a layer of gravel on the top, but the actual bedrock itself, which is what we were looking for, showed the real nice clean drop off just before it then shoots up again for the bit that extrudes up and causes the valley sides.
Right, thank you. Have you got any further remarks, Jacob?
Not a lot, but just when you're looking at the graph, you can almost see the different levels of energy that the flow had. So if you look at the graph, there's like varying levels of resistivity, and you can see which is like the lower, smaller sediment that's more compact. But yeah, in general, it was quite a big variation in resistivity on the cross section.
Yeah. Awesome. Would you say that was what you predicted, guys?
Somewhat. We predicted it to be more of kind of a just general U shape, and the closer that you got to the sides, the higher up it would be. We were expecting kind of the reverse, but in our other ideas, we did theorize this as well. This was another thing that we did think could have been a possibility. So it wasn't totally out of the picture, and now we see it. It does make sense. But so it's not a surprise, but it wasn't exactly what we expected.
No. Awesome. Well, glad we found out. Thanks, guys.